So exponential growth and decay is a way for us to describe, does my graph increase, go up, or does my graph decrease, go down? So let's talk about what our plans and our goals are for the lesson today. Okay? So the last time we did, let's say, parabolas. When we graph parabolas, we had to plug in the x in for like an equation, like 3x squared or something like that. But now with exponentials, they're J-shaped, right? So we can write that down. In previous lessons, name two characteristics of an exponential function. We have learned so far that the graph is like a J-shaped. Also, where is the variable? Where is the exponent now in these exponential graphs? Like, where is the x? Where's the variable? What position is it in the equation? If anybody has yesterday's notes out in front of them next door, where is the variable, the x? What position is it in the equation? Yeah. It's in the exponent. The variable is in the exponent. I think I'm running out of space, sorry. Okay? Also, you know how it gets really, really close to something and it never, ever touches? What is that thing that it gets really, really close to and it never touches? Yes, horizontal asymptote. The function, which is another way of saying the graph, function, let me write it properly, has a horizontal asymptote. And the last thing that I kind of want to add is that my graph is either, okay, so the word function and graph. So it either has, it's either increasing in shape, going up, or it's going down in shape, decreasing. That's what we've learned so far. So now let's talk about what we're going to do today. Today, like I said earlier, we're going to look at the numbers in the equation and we're going to decide what it will look like based on what numbers are in my equation. And we call that growth if it increases or decay if it decreases. In this lesson, you will be able to identify exponential growth and decay. So we'll be able to look at it and say, is it growth, is it increasing, or is it decay, is it decreasing? And then we're also going to talk about certain aspects of the graph. We're going to talk about how it grows, growth or decay factor, the rate at which it grows, and the initial value. These are all, oh, I spelled that wrong. These are all words, these three words, growth and decay factor, the rate, and the initial value. These are all words that are like labeled with a certain part of the numbers. So there's a certain number that means the rate. There's a certain number that means that it's a decay factor, for example. Got your goals written down? It's not practical. Okay, so here we go. Any quantity that grows or decays by a fixed percent, that's the whole point. How much does it grow by? A fixed percent. Is either a exponential growth or it's an exponential decay. All right? So we talked about this last week. Things that are exponential growth in the world. The interest that you can earn when you keep your money in a savings account. The population growing. And when I box this word fixed right here, it means like a fixed rate. Every day, 200 babies are born in Orange County or something like that. So it's like by 200, that's my rate that it's growing. But again, I don't know if that's even a right number. I just made it up. Or something's decaying. Things that can decay are like a species that dies out. What? Isotopes also decay. Okay, so on numbers 1 and 2, I'm going to give you the table of values. I'm not going to put you through that pain and agony. So let me give you the numbers for the x's and y's, but you have to graph them, so that won't be too bad, right? Okay. X and Y. Why don't you just listen and copy down? Don't stare at the screen. Look at your paper, listen and copy down. Here's your X, here's your Y. 2, 1/4. I'm sorry, -2, 1/4. -1, 1/2. 0, 1. 1, 2. 2, 4. Graph those ordered pairs right now, and I'll do the same. I know the graph looks a little bit different. Sorry about that. I'm going to make my dots really large, and they're not going to be accurately placed, so I just have to kind of give you that heads up right now. But 0, 1 I can accurately place. 1, 2 I can accurately place. 2, 4 I can accurately place. And also one thing I want to give you, 4, 16. It's like way up there, but it matters because it tells us a little bit about what the top of the line looks like. Okay, starting from the left side, just like the way you read a book in the words on a page. You start from the left and you go right. Is this graph increasing or decreasing? Starting from the left, going right. Is it increasing or decreasing? Increasing. Good to know. Okay, number 2, here's your table of values. I'll put them in the middle for ease. Here's your order pairs. Look at your paper, not the screen. -2, 2/9. -1, 2/3. 0, 2. 1, 6. 2, 18. Okay, go ahead and graph it. There's 1, 6. 0, 2. -1, 2/3. Won't be accurate. I just want to make the dot large so you can at least see it. -2, 2/9. Starting from the left, the way you read words on a page, you start from the left and you go to the right. Starting from the left, connect the dots, la 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 la. I may not be able to talk, but I can sing. Is this increasing or decreasing? Okay. What do you question down below? What do you notice about the graphs? They're increasing. What else? They're J's. What else? One's wider than the other one. Good. What else? Where's that line that they get so close and they never touch? What? It's not 1. The horizontal asymptote is at, Sam? 0. We call that the x-axis. The x-axis is the horizontal asymptote. And I just put that they both increase. But we already wrote that up top, so that's fine. Turn the page, please. Okay. Once again, I am going to give you the tables of values. Ready? Copy down. Get your T chart ready. X, Y. Draw your lines. Ready? -2, 4. -1, 2. 0, 1. 1, 1/2. 2, 1/4. Okay. So now, graph those order pairs, please. -2, 4. -1, 2. 0, 1. Oh, that's my y-intercept. 0, 1. 1, 1/2. 2, 1/4. Okay. All right. This, starting from the left, moving to the right. What's happening to this one? Decreasing. Whoa. Good job. Number 4. We'll do the same thing. Oh, look, this 0.4, if you felt like making it a fraction, you guys prefer decimals? Or, like, would you prefer to work with a 0.4 or a 2/5? Okay. All right, here's our tables of values. Set up your table of values first. -2, 12.5, 12.5. -1, 5. 0, 2. Oh, there's my y-intercept. 1, 4/5. Okay. Graph those. Oh, we'll just stop there. It's fine. Connect the dots. La, la, la. Good job.
I'm on a big slide.
This graph, what is it doing?
Decreasing.
What?
Decreasing.
Decreasing.
I wasn't here yesterday.
Okay. So what do you notice about both graphs?
They're both decreasing.
Let's use the word decrease, not backward J, huh? Tell me about the horizontal asymptote again. What is it?
0.
Yep. Horiz asym is the x-axis. Oh, some of it's covered up. Sorry about that. Okay. Some things that I need to have you do. Can you guys go back? Remember how our equations are always like y equals a times b to the x. In the b, that's like the parentheses, right? Can you guys go back to equations 1 and 2? Flip back one page and go to 1 and 2. Look at the b's. Look at 1 and 2. Flip back. Look at the b, the number in parentheses. Okay? Go to 3 and 4. Look at the b's, the number in parentheses. Oh my gosh. So is it maybe like coincidental that like the increasing ones or something and then the decreasing ones or something else? So let's compare equations 1 and 2. What about the b's? Tell me about the b's.
1 and 2 are whole numbers and maybe 4 are fractions.
1 and 2, the b is a whole number. Equations 1 and 2, the b is the whole number. You guys have a line to write it on. I chop mine off when I... Equations 1 and 2, b, the number in parentheses, is a whole number. Now what about equations 3 and 4? What did we decide about that? But there's something special, by the way. They're smaller than 1, but they're not negative. So they're in between 0 and 1. I write it like this. 0 is less than b is less than 1. That's how you would write in between 0 and 1. B is in between 0 and 1. 0 is less than b is less than 1. That's so important. Tell the difference between increasing growth and decreasing decay. Here is our little sum it up portion. Y equals a b to the x, exponential growth function. A is always going to be a positive number, so I'm going to put a is greater than 0. And we just said for growth that the b was bigger than 1, right? A whole number. So then for decay, the a is still a whole positive number. So that means a is greater than 0, positive number. And then my b is in between. Remember, it's a fraction, right? So it goes like this. In between 0 and 1, like that. 0 is less than b is less than 1. B is in the middle of 0 and 1. That's decaying. If b is a whole number, growth. If b is a fraction or decimal, decay. You could even remember that. If b is a decimal, decay. D-E-C, D-E-C, decimal, decay. Decrease, oh my gosh. Decimal, decay, decrease. Is it in your brain? All right, good. So now let's do a little quiz. A, is that increasing or decreasing? Growth or decay? Decay, decrease, because it's maybe a decimal or fraction. And B is what? Good. So now I'm going to quiz you, and we're not going to look at graphs. Now we're going to look at equations. The only thing you care about is the b, the base, the number in parentheses right next to the exponent. All right. I care about 3/2. Yes, 3/2 is a fraction, but 3/2 is 1.5. 1.5, that's bigger than 1. Is C a growth or decay? It's a 1.5. You're not solid enough for me to write anything down. You haven't made a decision in your brain. It's 1.5, which means it's bigger than 1. Is that growth or decay?
Growth.
Thank you, more people. D, 1.2.
Growth.
Is that bigger than 1? Growth.
Growth.
E, by the way, is this. Y equals 1 times 2 to the x. Because you know how there's always an A in front, but if we don't list an A, then it's automatically a 1, invisible 1.
Yeah.
Is E a growth or decay?
Growth.
Okay. 1/4. Is that a growth or decay?
Okay.
Let me ask first. Thank you. This says y equals 1 times 0.5 to the x power. Yeah, half, right? 0.5? All right, now I just need examples from you. So I need you to tell me some that you think. Somebody give me a sample equation for a growth, exponential growth. Johan.
Y equals 2 times 3 to the x.
What makes this a growth is that there is a 3 in the B position, right next to the exponent. Somebody else give me a growth. Elijah.
Y equals 1.7.
Yeah. It's more than 1 by 7/10, 0.7. Flip side now. I need a decay. I need a sample decay equation. 1, 2. Go ahead, you first.
Y equals 2 times 0.4 x.
Yes. It's less than 1. Sam?
Y equals 3, 1/3 x.
Yeah, no, that's totally fine.
Wait, we did it.
It says y equals 3, parentheses, 1/3 to the x power.
So is 0.22?
Yeah. So could you successfully look at an equation and identify whether it's growth or decay?
Yes.
That's the takeaway from this slide right here. Okay. So now there's something I need to talk to you about that we'll talk about the format. So A, here we go. So copy these things down. I'm going to kind of break down the equation for you. Break it down. A is the initial value. Okay. When B is bigger than 1, that's what we call growth, right? Now, B is usually bigger than 1. Sometimes it's like more than 1. It's like 2 or 1.5 or 3 or 4. So I care how much more than 1 it is. That's important in this lesson. So B is called the growth factor. So write down growth factor for B. Now, it matters how much more than 1 it is. So I can do a little subtraction in my head, and I can say 1 plus how much is my B. Okay, so I just wrote down 1 plus R equals B. The R is called the growth rate. The R is called the growth rate. So let me give you a sample so that your R, hold on, let me finish my little sentences here. I care how much more than 1 B is. So let's say I wrote this down. Y equals 1.7 to the x. I want to know how much more than 1 is this 1.7. How much more than 1 is 1.7? Do you guys get that you are basically doing 1.7 take away 1? Like I have 1.7 in parentheses, that's my B. 1 is the number that is like, I have to have a 1, but how much more than? So it's 0.7 more. So what I would do is something like this. 0.7 would be my growth rate for this example. Let me do another one in black. Y equals 2 times 3 to the x. Okay, I need my parenthesis to be bigger than 1. How much bigger than 1 is 3? 2. 1 plus 2 equals 3. 2 is my R. 2 is my growth rate. So that's like a big thing. How much more than 1 is it for growth? Is that clear? Are my two examples, my blue example and black example, kind of give you a little bit of understanding on it? Okay, moving forward. Oh, I never said what X was. X is time. Can you put a little arrow and point to X and say time? Okay. All right. A. A is the same thing. A is my initial value. Y equals A times B to the X. A is my initial value. So now we're doing decay, all right? Decay means that B is in between 0 and 1. Remember our special way to write it? 0 is less than B is less than 1. That's called decay. So B is going to be my decay factor, because now we're doing decay. Decay factor, we care how much less than 1 it is. So now I'm caring about, well, it's going to be less than 1, but how much less than 1? So this is going to be a little subtraction problem. 1 take away R is going to be my B. My R is called the decay rate. X is time. Let's not forget it on this slide. R is my decay rate. And it's 1, in my opinion, I think that it's best to write 1 minus B equals my R. So I'm going to have 1 and then I'm going to subtract B and I'll know. Okay? So here, now, let's do some samples. I'll do one in blue. Y equals 7, crazy number 7, 0.4 to the x power. I look at the parentheses and I say, gosh, that's less than 1. How much less than 1 is it? 1 minus 0.4 equals what? You said 0.6? 0.6 is my R. So now for decay, I care by how much is it less than 1? How much less than 1 is B? Before, on growth, I cared about how much more than 1. So I get to the next thing and put this into practice. So I'm going to try and get number 1 done with you, and then you are going to do 2, 3, 4, 5, 6, up to 6 for homework. So let's talk about what this is. Look at the equation. The 1.8 is the most important part. Is that growth or decay? What is my initial value?
3.
Thank you. So now I care about what is B? What is my growth factor? Remember, that's B. What is it? 1.8. Then the big question, the rate, how much more than 1 is it? 0.8 more than 1. That's my R. Okay? R equals. Number 2, is this growth or decay? What's my initial value? Is it, my B is what? 1.04. Now, how much more than 1 is 1.04? Yay! Your job is 3, 4, 5, 6 tonight for homework, okay?